Hello students, beginning with one more physical chemistry chapter, that is chemical kinetics. This is very important for your competitive examination point of view. So what is this chemical kinetics? Why we have to study this chapter? In your first PU classes, first PUC nalli you studied thermodynamics. Thermodynamics chapter study ಮಾಡಿದ್ದೀರಿ and also you studied chapter equilibrium. ಇವೆರಡು ಚಾಪ್ಟರ್ಸ್ ಗಳನ್ನು ಕಲಿತಿದ್ದೀರಿ. So chemical equilibrium. You studied these two chapters. Why we have studied this thermodynamics chapter? Thermodynamics ನಲ್ಲಿ ಏನು study ಮಾಡಿದ್ದೀರಿ? Okay, apart from the first part of thermodynamics, okay, now second part ಅಲ್ಲಿ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ? We consider thermochemical equations and feasibility of many type of chemical reactions. You heard about spontaneous chemical reactions. ನಿಮಗೆ spontaneous chemical reactions ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತಿದೆ. So ಏನು spontaneous chemical reactions ಅಂದ್ರೆ? The reactions takes place by itself without any external agencies or without any external aid. Okay, ಅದರಷ್ಟಕ್ಕೆ ಆಗುವಂತ processಗಳು they are called as spontaneous process. For all spontaneous process, Gibbs free energy change or standard Gibbs free energy change is always less than 0. ಅದು ಹೇಗಿರ್ತದೆ? That is always less than 0, that is negative. Delta G naught ಯಾವತ್ತು minus ಇರ್ತದೆ. So this term predicts the feasibility of chemical reaction. Feasibility ಅಂದ್ರೆ ಆ reaction ಆಗ್ತದಾ ಇಲ್ವಾ ಅನ್ನೋದನ್ನು predict ಮಾಡ್ತದೆ. If any reaction has delta G naught is equal to less than 0 or if it is negative, delta G naught negative ಇದ್ರೆ less than 0 ಇದ್ರೆ, so ಆ reaction ಆಗ್ತದೆ, that reaction is thermodynamically feasible. Okay, thermodynamically ಆ reaction ಏನಾಗ್ತದೆ feasible ಆಗಿರ್ತದೆ. That means you can carry that reaction spontaneously. ಏನು external agencies ನ help ಇಲ್ಲದೆ ಆ reaction ಆಗ್ತದೆ. In second chapter, in the last chapter in physical chemistry, first ನಲ್ಲಿ ಕಲ್ತಿದ್ದೀರಿ chemical equilibrium ಬಗ್ಗೆ ಕಲ್ತಿದ್ದೀರಿ. So what is this chemical equilibrium? Why we have studied it? ಯಾಕೆ ಸ್ಟಡಿ ಮಾಡಿದ್ದೀರಿ? It is used to study the extent of chemical reaction. Okay, before the completion, some reactions attain equilibrium. ಕೆಲವು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಆಗ್ತದೆ, they are irreversible processes. Irreversible ಅಂದ್ರೆ ಒಂದೇ ಸೈಡ್ ಅಲ್ಲಿ ಮಾತ್ರ ಆಗ್ತದೆ towards forward direction. ಈ ಹೆಚ್ಚಿನ ರಿಯಾಕ್ಷನ್ಸ್ಗಳು ಏನಾಗಿರ್ತವೆ? they are all equilibrium reactions. To predict the extent of chemical reactions, ಒಂದು chemical reaction extent ಅನ್ನು predict ಮಾಡಲಿಕ್ಕೆ means how much percentage of that reaction is completed before attaining equilibrium. ಎಷ್ಟು percent complete ಆಗಿದೆ, how much percentage of reaction is remaining, reactants are remaining for the next continuation of the reaction. ಅದೆಲ್ಲವನ್ನು ಸ್ಟಡಿ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ we have to study chemical equilibrium. Understood? Why thermodynamics is needed here? It is to predict the feasibility of reaction. It is to predict whether that reaction takes place or not. If delta G naught is positive, that reaction does not take place. If delta G naught is negative, then that reaction takes place. Then why equilibrium? Chemical equilibrium is used to predict the extent of reaction. It is used to calculate how much percentage of the reaction is completed before attaining equilibrium. What is the amount of reactant left? What is the amount of product formed? Okay, you have written Kp and Kc and all in first PU itself. Now, what is this chemical kinetics? Why it is required? A chemical kinetics ಯಾಕೆ ಬೇಕು? So this chemical kinetics is used to predict the rate of the chemical reaction. Okay, there are many chemical reactions which are thermodynamically feasible but kinetically not possible. For example, conversion of graphite into diamond is thermodynamically feasible. Okay, diamond ಯಾವುದು ಗ್ರಾಫೈಟ್ ಅನ್ನು ಡೈಮಂಡ್ ಕನ್ವರ್ಟ್ ಮಾಡಬಹುದು. ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಫಾರ್ ದಟ್ ರಿಯಾಕ್ಷನ್ ಇಸ್ ನೆಗೆಟಿವ್. ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಗಿಬ್ಸ್ ಎನರ್ಜಿ ಚೇಂಜ್ ಏನಿರ್ತದೆ, ಫ್ರೀ ಎನರ್ಜಿ ಚೇಂಜ್, ದಟ್ ಇಸ್ ನೆಗೆಟಿವ್. ಥರ್ಮೋಡೈನಮಿಕಲಿ ದಟ್ ಕನ್ವರ್ಷನ್ ಇಸ್ ಪಾಸಿಬಲ್. ಗ್ರಾಫೈಟ್ ಅನ್ನು ಡೈಮಂಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗುತ್ತೆ, ಬಟ್ kinetically it is not possible because it takes lot of time. Nearly 1 ವರ್ಷ 2 ವರ್ಷದಲ್ಲಿ ಆಗೋದಿಲ್ಲ, 10, 50 or 100 years ಬೇಕಾಗಬಹುದು. ಸೊ ಅಷ್ಟು ಸ್ಲೋ ಆಗಿ ಅದು ಪ್ರೊಸೆಸ್ ಆಗ್ತದೆ. ಸೊ what is the necessity of studying this chemical kinetics? It is used to study the rate of a chemical reaction. So kinesis means movement. Okay, chemical movement ಅಥವಾ reactant ನ change ಅಥವಾ product ನ change ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು chemical kinetics ಯೂಸ್ ಮಾಡ್ತೇವೆ. Understood? Okay, in order to study a complete chemical reaction, ನಮಗೆ thermodynamics ಗೊತ್ತಿರಬೇಕು. We have to know about thermodynamics, chemical equilibrium as well as chemical kinetics. Now, let us see what is this kinetics, what is kinesis and all. we begin this chapter with the definition of rate of the reaction, or this is also known as the velocity of reaction. Okay, ಇದಕ್ಕೆ velocity of reaction ಅಂತ ಕೂಡ ಕರೀತಾರೆ. So rate is nothing but change in the concentration of reactant and or product in unit time. Okay, and ಅಥವಾ ಎರಡು ಬರೀತಾರೆ. Change in the concentration of reactant or product and product in unit time. ಅರ್ಥ ಆಗ್ತದಾ? ಈಗ ಯಾವುದೋ ಒಂದು ರಿಯಾಕ್ಟೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನಿಮಗೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಯು ಹ್ಯಾವ್ 1 molar ಆಫ್ ಎನಿ ರಿಯಾಕ್ಟೆಂಟ್ ಆರ್. ಆಫ್ಟರ್ 5 minutes, okay, it decreases to 0.5 mole or molar. So here you can calculate the rate of the reaction. ಇಲ್ಲಿ ನೀವು rate of the reaction calculate ಮಾಡಬಹುದು. Rate is nothing but change in the concentration of reactant or product with respect to time. ಹೇಗೆ? So rate is equal to change in concentration 1 minus 0.5 divided by ಎಷ್ಟು ಹೊತ್ತು? 0 ದಿಂದ 5 minutes. So like this you can calculate what change in concentration of reactant divided by total time interval. ಅರ್ಥ ಆಗ್ತದಾ? Change with respect to time. So this is about the definition of rate of a reaction. Now, with respect to reactant and product, we can define the rate like this. It is nothing but rate of decrease in the concentration of the reactant. Understood? What is rate? Rate is nothing but it's a change in or decrease in the concentration of any one of the reactant, or rate of increase in the concentration of any one of the product. Understood? ಯಾವಾಗ ರಿಯಾಕ್ಟೆಂಟ್ ನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ, when the concentration of reactant decreases, at the same time concentration of product increases. Rate is nothing but the decrease in the concentration of any one of the reactant with respect to time, or rate is nothing but rate of increase in the concentration of any one of the product. ಹೀಗೂ ಕೂಡ ಡಿಫೈನ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗ್ತದೆ ಯಾವುದನ್ನು? ರೇಟ್ ಅನ್ನು. ಅಂಡರ್ಸ್ಟುಡ್? ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ರಿಯಾಕ್ಟೆಂಟ್ ಆರ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಪ್ರಾಡಕ್ಟ್ ಯು ಕ್ಯಾನ್ ಡಿಫೈನ್. ನೌ ವಿಲ್ ಗಿವ್ ಯು ದ ಎಕ್ಸಾಂಪಲ್. Consider the hypothetical reaction. ಒಂದು reaction ಇದೆ, R2P, reactant to product. Here 1 mole of R produces 1 mole of product P. Reaction ಅಲ್ಲಿ 1 mole of R react ಆಗ್ತಾ ಇದೆ, so 1 mole of product P ಸಿಗ್ತಾ ಇದೆ. Let it be. Now if R1 and P1 are the concentration of reactant and product at time T1, ಯಾವುದೋ ಒಂದು time interval ಅಲ್ಲಿ, at any interval, time interval, ಯಾವುದೋ ನಮ್ಗೆ ಗೊತ್ತಿಲ್ಲ, at any one time interval, the concentration of R and P are R1 and P1. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, concentration ಹೇಗೆ ಬರೀತೀರಿ? You have to write the reactant in terms or inside the square bracket ನೊಳಗಡೆ ಬರೀಬೇಕು. ನೆಕ್ಸ್ಟ್ ಸ್ವಲ್ಪ ಹೊತ್ತು ಬಿಟ್ಟ ಮೇಲೆ, after certain time, at time T2, the concentration of reactant and product changes to R2 and P2. Initially ಎಷ್ಟಿತ್ತು? Okay, at time t equal to 0, ನಾವು ಯೂಶುವಲಿ ಏನು ಮಾಡ್ತೇವೆ? Concentration is taken as R0 and concentration of product is taken as P0, that is equal to 0. ಯಾಕೆ? Why? At time t equal to 0, no product is formed. Reaction is not yet started now. Okay, as time passes, at 1 second, 2 second or at 3 second, slowly the concentration of reactant decreases, product increases. At that time we take it as R1 and this as P1. Okay, at time t is equal to 2 second. If this is the concentration of reactant and product, after 10 second it further changes. ಇದು ಇನ್ನೂ change ಆಗ್ತದೆ. It may become R2 and this becomes P2. It increases and it decreases. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಲ್ಲ? So like this we can write. Now according to the definition, see here, the total time interval is to change in time delta t is equal to T2 minus T1. So ಇಷ್ಟು time ಅಲ್ಲಿ between this time interval between 2 seconds to 10 seconds. So what is the change in the concentration that we have to find? That is the rate of the reaction. Or you can start from 0 second to 10 second, 0 to 5 second or 0 to 1 minute, like this you can find. ಅದನ್ನು ಹೇಗಾಗುತ್ತೆ ಹಾಗೆ ಬರೀಬಹುದು. Here I have taken the first time interval as T1. ಇದನ್ನು ನಾನು T1 ಅಂತ ತಗೊಂಡಿದ್ದೇನೆ. Second time interval T2 ಅಂತ ತಗೊಂಡಿದ್ದೇನೆ. Now we have to find the rate of the reaction between this time interval. ಇಷ್ಟು ಟೈಮ್ ಇಂಟರ್ವಲ್ ಅಲ್ಲಿ ಎಷ್ಟು ಚೇಂಜ್ ಆಗಿದೆ? ಬಿಟ್ವೀನ್ 8 seconds and 10 seconds ಎಷ್ಟು ಚೇಂಜ್ ಆಯಿತು ಅನ್ನೋದನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ನಾವು ಸಿ ಡೆಲ್ಟಾ ಟಿ change in time T2 minus T1. Okay, delta R change in the concentration of reactant R2 minus R1. Delta P P2 minus P1. Okay, final minus initial final minus initial. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? ಇನಿಷಿಯಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಎಷ್ಟು? ಅದು R1 reactant ಗೆ, P1 initial P ಗೆ product ಗೆ initial concentration P1. Now delta R is the change in concentration of reactant at this time interval delta T. Delta P is the change in the concentration of product at this time interval delta T. Understood? Yes. Now I can write the rate of reactant, rate of disappearance of R, rate of reaction with respect to reactant is decrease in the concentration of R divided by time taken. Decrease in concentration of R divided by time taken, that is delta R by delta T. Here we put negative sign because it is decreasing the concentration. Concentration decreases, it indicates concentration of reactant decreases. At the same time, in terms of product, we can write rate of appearance of product P is equal to product na concentration ಏನಾಗ್ತದೆ? Increase in concentration of P divided by time taken, that is equal to plus delta P divided by delta T. Why it is plus? Because concentration increases. In any reaction, rate of disappearance of reactant is always equal to rate of appearance of product. Thank you.